Hello everyone and welcome to MechLearn 360. So in this video I want to solve a problem with you to illustrate the concept of the oblique axis. Alright, so let's go ahead and read the problem together and solve it. So we have a steel pipe of 12-inch outer diameter and it is fabricated. So let's write the values as we go. So 12-inch outer diameter, fabricated from 1-inch thick plate. So the thickness is 1/4 inch by welding along a helix that form an angle of 25 degrees with a plane perpendicular to the axis of the pipe. So in fact, theta is actually 25. Knowing that the maximum allowable normal and shearing stress in the directions respectively normal and tangential to the weld. All right. So the tangential and then the normal stresses on this plane is 12 ksi and then 7.2 ksi. Now we are to determine the magnitude P of the largest axial force that can be applied. So interestingly, they are looking for P. All right. So now to solve this problem, I want to sketch something here which represents the surface in question. Now, if you look at this surface, this cut surface where you have the word, we can actually sketch the surface as this. If we decide to cut through, we will have something like this. Okay. Now, interestingly, this normal force, okay, so this is what the question was saying. There was a plane normal to this, okay, and then the angle that the inclination makes with the normal plane, that plane we are talking about is sort of normal to this cylinder, okay. So the angle of inclination is what? 25. All right. So this angle here is 25. But we have our load P coming this way. So P is coming downwards in this direction. P. However, there is our shear force and then our normal force. So the normal force on this weld here will always be normal. In other words, perpendicular. So it's sort of perpendicular. Let's call that normal force F. Okay. And then there is also this shear force. All right. But the shear force is actually going to act along the weld. All right. So let's call that shear force V. Now the angle which is between the shear force, so this angle between the shear force and the normal force is always 90. All right. But we are told that this angle here is 25. Therefore, if this this is normal to this, then we expect that the angle here must be 75 because I have 25 here, so here must be 75. However, F and then V are perpendicular, therefore this angle must be what? Adding up to 90, which means over here too is going to be 25. All right. Having done this, we can actually sort of bring the vein here, project the vein onto this as this. All right. So technically, you see this triangle, then we can say that don't forget that our F and then our vein they are having angles of what? 90. All right. From here, we can say that cosine 25 will be adjacent. But what is the adjacent? The adjacent is actually the F, which is this side, okay, divided by the hypotenuse, which is P. The 90 degrees is facing P. All right. So we can say that F is P cosine 25. All right. So we also know that sine 25 is so opposite, which is V over P. Therefore, V is P sine 25. All right. So we are done with this part. But in fact, the formula for the normal stress is actually the normal force divided by A theta. So if I say A theta is sort of the area of the inclined angle. So think about this. Let's say you have this cylindrical area here, and then there is, okay, this is what I'm trying to say. You have a cylindrical area here, which is the normal. And then there is this inclination, okay? All right. So, in fact, the area along the curved surface, along the inclined surface, we call it A theta. And the area, which is the normal area, is actually A naught. But the angle between this and this is what? 25. So what can we say? If here is A naught and this side corresponds to A theta, then we can say that cos 25 will be A naught over A theta. In other words, A theta must be A naught over cosine 25. If we put everything inside here, then our normal stress will be P cosine 25 divided by A naught multiplied by cosine 25. In other words, our normal stress will be P over A naught cosine 25 squared. All right. So that is it for you. But then, in fact, that is the P that we want. From the question, the normal stress was given. All right. We know D out, and then we know the thickness. All right. So let's calculate the original area. Okay. All right. So this is the formula we have. But then, to calculate the original area, because we have the outer diameter and the thickness, we can actually solve for the, so this is what I'm saying. We have an inner diameter, then we have an outer diameter. So we have a thickness, and this one is also some thickness, and this is the inner diameter. So we can say that the outer diameter is the inner diameter plus twice the thickness. Therefore, the inner diameter will be the outer diameter minus 2 times the thickness. So it's going to be 12 minus twice of 1/4. Now let's pick our calculators. So 12 minus 2 times 1/4. All right. And what do we get? 11.5. So 11.5 inch. Therefore, we can say that our outer area will be pi over 4. into d naught squared minus di squared, and this is given by pi over 4 into our outer, which is 12, minus our inner, which is 11.5. Sorry. So we have 12 squared minus 11.5 squared. Therefore, our a naught will be pi divided by 4 into 12 squared minus 11.5 squared. Okay. 9.23 squared inch. All right, so that is it for you. Okay, so now this is the formula for the normal stress. And then, so let's call that formula equation 1. Let's find the formula for the shearing stress. For the shearing stress, is going to be V over A theta. But V is P sine theta. Then we divide it by A naught divided by cosine theta. So it will be P over A naught cosine theta sine theta. From here, our tau can be written as P over A naught cosine theta sine theta. Now, interestingly, what we have here is equation 2. Let's go back. You see, he said that we should find the load, right? The magnitude P of the axial force. Okay. So then, if sigma is 12 ksi, what will be P? Okay. So let's put it inside and see what will happen. So we know that the normal stress is what? P A naught cosine squared theta. But if sigma is 12 ksi, what will happen to P? So it will be P over original, which is 9.23. 9.23 cosine squared 25, right? So from here, we can say that P will be 12 multiplied by 9.23, sorry. Then I divide the whole of this by cosine squared 25. Therefore, P based on the normal stress will be 12 multiplied by 9.23 divided by cosine 25 squared. $134.84 KIP. So that is the load. Or maybe let me just write it as pound force. Sorry. Okay, KIP. And then based on the shearing stress, we have P over A naught cosine theta sine theta. So if we have this, then what can we see? So we can say that, okay, the shear stress is 7.2. Okay. So if the shear stress is 7.2, what will happen to P? That is what we are interested in. Cosine 25 and then sine 25. So P will give us 7.2 multiply by 9.23. Then we divide everything by cosine 25 and then sine 25. And that will give P as what? 7.2 multiplied by 9.23. Then I divide by cosine 25 multiplied by sine 25. So based on that one, P will be 173.5. All right. So the problem has been solved. Thank you very much for watching.